Well, good afternoon, everybody. Good afternoon again for those of you that I said that to 5 minutes ago. We're going to get started. It's about time for the last session of the day. I appreciate you all sticking around for the what I've really been excited for one of the sessions throughout the entire conference. We've heard a lot through the last couple of days around this idea of AI. Anybody hear a little bit about AI the last couple of days? It's going to be big. It's going to be big. But one of the things that I found interesting is, and this is not a criticism of any of the sessions that I've seen earlier, but there's been a lot of talk about AI's coming or AI's here. Not a lot of talk about what it's doing and examples. For me, that's always one of the best ways that I've always found to learn is show me what someone has done, what they learned, and how they're using it. Show me it practically being used. And that's what we have the privilege of spending some time this afternoon doing. We've got two organizations that are going to share their stories about how they're using AI and how they've been able to leverage it within their organizations. Two separate presentations, each of which is going to explore a really interesting case study that I'm really interested in looking forward to. First, we're going to have Matt Wicks from the Virtual Forge, who's going to share his story, and then James Cook from IBM. And then we'll have some time to do some Q&A at the end there. So I'm going to get out of the way because I'm really excited about the session myself. And with that, Matt, I'll turn it over to you.
Brilliant. Thank you very much. Okay, and thank you to everyone for joining us in the final session of the day. Very much appreciated you all staying and coming along to the session, and very well attended it was too. I had a feeling it would be less attended than this, so this is very, very cheerful to find. So just to give you a very brief little bit of background, the Virtual Forge is an organization, and we have three different specialities within the organization. We specialize in software development, we specialize in data analysis and working with data, and we specialize in cloud delivery. And the three of those come together in order to allow us to be able to do projects which actually work across artificial intelligence in a variety of different ways. So what I'm going to do for the next 25 minutes or so is talk about, I'm going to talk about some of our experiences. I'm going to talk about some of the tools that are actually out there. Some of you may be familiar with them. Some of you may not be familiar with them. They're designed to be things that are practical, things that you can take away and pick up and carry on and experiment with in your own environments. They're not things that require huge mainframes or huge systems. They're not things that necessarily require data scientists to work on them. They're things that have very practical, very immediate applications. And they're things that form the basis of a lot of the work we do with our clients in various different organizations. It also, I think, shows the breadth of what artificial intelligence is and how it's actually being used nowadays in multiple different ways of working. So when we talk about artificial intelligence in learning, quite often we talk about adaptive learning, we talk about predictions, we talk about personalized learning paths, we talk about the great promise of being able to take things and create that highly detailed, extremely personal path for a learner to be able to follow to their end goal, which will be different for every learner and will deliver results which actually ultimately will allow us to achieve 100% competency for 100% of people all the time. Now, of course, we're nowhere near that. But where we are is with a set of I say, very powerful tools which can be used, and some of them are in your houses nowadays. Some of them you will have seen being used in multiple different environments all over the place. And they in themselves are useful tools, and then when they're actually built into applications, into LMSs, into learning tools, into content, they also manage to deliver a whole other level of opportunity and result. So in general, AI applications, AI experiences are data-driven. That kind of goes without saying. They're driven by data. They're driven by the data that you put in, but more often, they're driven by the data that the tools themselves collect. It doesn't have to be computer-based, and that's also a very important thing, that actually a large part of a successful AI experience in learning is one that may be driven and create outcomes which are driven by data and by computer-based learning. But the reality is the most effective thing is it's just a tool to manage a pathway that a user goes through, that a learner goes through. A lot of the way in which AI is in the world now and is being used nowadays is facilitated AI. It's AI as a service. It's things that are out there which can be used in different ways. And it tends to be, if you follow the path through, taking a large amount of data, being able to see things in that data that the human couldn't see as quickly or at all, and then deliver a result out of that. Now that might be by using text analysis. It might be by using image and video recognition. It might be being able to use prediction. It might be being able to recognize the spoken word and translate that into text, or the other way around. All of those things are actually using a multiplicity of the underlying forms that artificial intelligence allows you to have. So a lot of the work we do A lot of the work we do is using one or other of the cloud providers. There are many, many others around here. And the reason I mention this is because I think it's important to know, and I keep coming back to this, that out there today, a lot of these things are available for you to be able to use in different ways. And they don't always require a great amount of technical skill. They're things that you can take away. Most of the examples that I'm going to show you today are things that you can take away and actually start to work on immediately. A lot of the work that we do takes these as our starting points, which I'll talk about. So image analysis is a very, very good example. Just to give you a really simple example, this is Teachable Machine. Some of you may or may not have seen this. I'm going to give you a little demonstration of how this works, because not only is it a good example, it's also a very good example of exactly what machine learning, what artificial intelligence is. So you see this very handsome chap on the left. He's going to be holding up a banana and training the machine that when he holds up a banana, it's going to play this little animated GIF on the left-hand side. He's then going to bring in, rather obscurely, a flower and train the machine by collecting data about that when that picture appears or that situation appears, the machine on the right-hand side should play this particular animated GIF. And then the final part is to train that when it sees an orange, it should then play the GIF on the right-hand side. The important thing here is actually at a fundamental principle, this is just getting into exactly what machine learning AI is. It's learning to do something by taking in large amounts of data, in this case images, it's analyzing that data, and it's making a judgment and performing an action based upon that. It's being able to take the banana, and there it is, it's making an accurate judgment, getting a bit confused there with the flower, the orange, and so on and so forth. And ultimately, however complicated whatever it is you're doing, or whatever it is that we're building, whatever it is you're building is doing, fundamentally, this is really what you want artificial intelligence to do. You want it to be able to recognize your bananas. You want it to be able to take, he's having too much fun now. You want it to be able to take in information, to be able to self-analyze that data, perhaps with some guidance, which the guidance is represented by the training in the middle, and then the output is some outcome that comes from this as well. As I say, this is available online. At the end of this process, you'll all be receiving a PDF, I believe, of all of the slides that are given to this presentation. You're going to follow this and have endless hours of enjoyment doing this. But there is a really fundamental and important point there as well. Okay. This is one of the things that we've been able to use for a client of ours, Pedagogo. So this is an assessment-based tool. The assessment-based tool effectively is something that allows students, apprentices, to be able to take assessments online without having to go into a modified environment to be able to do that. And the process behind that makes use of a number of different technologies, one of which is using image recognition to be able to do this. Now, if you are, there are a lot of image recognition tools out there. We use AWS Recognition, which is a tool that allows you to take image-based recognition. It allows you to take video-based recognition. So it will run through a video. It will analyze the things that you've seen. You've seen there the Google example. There are many, many other examples of that. But the practical, fundamental side of it is it's taking this information that's being created and it's using it to create an outcome. In this case, it's using it to create to recognize and validate an identity. It's also being used elsewhere within our system to be able to recognize objects and allow you to select objects at particular points in time. It's being used nowadays a lot by brands to be able to recognize and to see how to trawl through the large amount of social media and recognize either logos or vehicles or whatever it is you're trying to do. And again, the same thing which is important here is that, if you want to make use of this within a learning environment, it's there, you can go on and you can do this very simply. The second example that I want to bring up is one that I'm absolutely sure you all recognize. So this is much more driven towards content creation rather than outcome creation. So once again, artificial intelligence allows you to go through, to analyze voices, to record voices, to start to break down those voices into specific sounds, to then represent those sounds in a way that can be turned into data. That data can then be used to create interactions which make use of that sound. So a typical example of the sort of thing that we've done in systems is we've built a lot of help systems. So I'm sure you've all seen them in websites, where you go to the website, you click on a button, and you can type or you can speak into that system. And when you type or speak into that system, you get a response, which is either a slightly dodgy voice coming back to you, or it's text which is saying, do this or do that. Again, this is leveraging the same process behind the scenes. You know, just as with the images, you're collecting the data, you're making a judgment. The same thing here, as I'm going to show now, with voice recognition. Voice recognition is increasingly everywhere. The example I gave of the work that we've done with the help bots on web pages, again, those can be built using cloud provider systems. They can generally be built without any coding whatsoever. They can be input into mobile applications. They can be input into back-end systems. But of course, the next extension of that is the home speaker. I mean, I suspect a lot of people have got Alexa or Echo, Alexa or Google Home, or other speakers are available. And they work on exactly the same basis. They allow you, the hard bit in many ways is already done. The hard bit is there. It will allow you to speak, it will understand what you say most of the time, and then it will deliver back the response that's in there. Now, in order to create what's called a skill for Alexa, you know, there is a little bit of coding required. This link here, which, you know, again, you'll have available at the end, allows you to build what I'm going to show you. Took less than an hour to build. And the important point is that if you link this into your existing system, so the example I'm going to show here is an example that we used as a baseline, or we've used as a baseline for integrating with learning management system. And the point is that what you're actually doing, let's take this example here. You're taking information about a user, and you're making judgments based on that user, whether it's a rule-based or a more cognitive element. And you're doing that within the learning management system anyway. You're doing that within your curriculum anyway. The bit that's being added in here is the facility to be able to deliver this in a different way. That's the first part of it, the facility to be able to do a voice-recognized item. The second piece of it is that as that data builds up, you then have the engine behind, which I'll show you in a minute, which allows you to make much more informed, much deeper choices, because you're actually changing the path that the learner is following based upon the outcomes of their learning. So let's take a look here at this example here. This
Alexa, launch Learning Technologies demo.
Welcome to Driving Test Theory Tester. I will ask you 3 questions. Try to get as many right as you can. Just say the number of the answer. Let's begin. Question 1. When you're overtaking a cyclist, you should leave as much room as you would give to a car. What's the main reason for this? 1. The cyclist might get off their bike. 2. The cyclist might have to make a left turn. 3. The cyclist might speed up. 4. The cyclist might swerve.
The answer is 4.
And again, an important thing
That
to say
answer
here,
is correct. Your score is 1. Question 2.
an important thing to say here as well is that when you're building this sort of application, Alexa is just one way of getting that information in. Often our applications are making use of a combination of mobile and Alexa or spoken word. And the reason for that is obviously because you want to be able to deliver this in as many formats as possible in order to maximize the data that's underpinning the choices that you're making. Okay.
Where on a motorway would you find green
So
reflective
we go through this.
studs? 1. Separating driving lanes. 2. Between the carriageway and the central reservation.
If we had a
3.
little bit more time, I'd do a
Between the
straw
hard
poll of the
shoulder and
correct answers to this
carriageway.
to see how many people
4.
get it right, but
At
we'll
slip
leave it
road
where it is.
entrances and exits.
The answer is 1.
That answer is wrong. The correct answer is 4. At slip road entrances and exits.
So here
You
we
got 1
have,
out of
obviously,
3
a very
questions
simple
correct.
outcome.
Thank you for playing.
Sorry, wrong way.
You have had some issues with some
We have a very simple outcome based upon this, and the simple outcome is that given the correct or wrong number of answers, we present you with some further training that can be done, and we also make a judgment that because in your previous examples of your work, you've had the most successful outcomes by watching videos, we're then able to serve up those different elements. So by making this dynamic, you're not only allowing content to be created vocally, you're also then being able to generate the outcomes based upon what's out there on the internet, based upon the successful outcomes that users have had, the methods of delivery that led to those successful outcomes as well. As I say, very simplistic demo here, but the principle is the same thing. These tools are out there to be able to be used very, very simply. Okay. The next thing to bring up here is this is a very interesting. People often talk about being able to predict results from to be able to predict results based upon statistics that are collected. I'm able to go through. I'm able to collect all of the information about users. Can I therefore predict next year's users? Well, it's not as simple as that. It's kind of like coming in here and saying, can I create an algorithm to predict who will sit where? And actually, the whole process is very, very different. And then obviously, as soon as people start to sit in one area, congregate and so on. So we have here an example of HarvardX, which is a massive online course which was launched, and it's a series of online learnings, really, which was launched in, I think, 2012. And over the years, they've been successfully putting content out. But what was interesting is there is a research paper, which I've linked to again here at the bottom. And this research paper is an investigation into can they create an algorithm to predict whether or not users are successful. Because this course, when it first started, the first year they had 350,000 people sign up. By 2014, they had 2.4 million people sign up. But they were getting very low success rates, and they wanted to understand who are the people who were successful. And so a group of analysts did this research, and it's a very interesting research. It's only about 10 pages. It's quite an interesting academic paper. And they got to an understanding by using two different types of machine learning algorithms. They were able to predict with a 96% certainty whether somebody would be able to go through and complete that course or not. Now, again, I'm always slightly nervous of statistics like that because, is it repeatable in different circumstances? What was the logic behind it? And so on. But it is a really interesting read if you're interested in this sort of thing. But more importantly, the fact that you can take that information and start to make predictions is actually something that is potentially hugely useful, both to every type of environment where a learning outcome has a cost associated with it. And this is something you can actually do right now. So this is a tool that we use a lot. This is Amazon's machine learning tool. There are many other cloud providers that do this. So just taking you through really, really quickly this is some statistics where we've taken the degree of study time for typo materials, the degree of repetition. So this is an engineering class, various statistics about how long they've spent on something, how long they've spent on related things, what is the amount of time that they've spent studying, what was their last exam score. And one of the things that you can do is take stacks of information like this. This is a very small data set. And without going into any code here, you can upload this into Amazon's tool or any of the other cloud providers' tools. And it will understand almost immediately. It can read the types of data you've got in from the headers in the row, in the top of the spreadsheet. And you'll see here it will pick out the correct terms, the different categories. And then you select which is the one that you want to predict. So here I've got all these statistics, and actually I want to predict the learning outcome, which is this one, which falls into a band of low, medium, or high. So it's a relatively simple prediction to be able to make. It will then go away and it will run for about 10 minutes, depending on the data size, or 3 hours, depending on the data set size. It will run a series of predictions, and it will say, okay, it will compare 30% of the data that you put in with the actual result. So it's evaluating itself all the time to be able to do this. Now, we use this a lot in building applications for modeling data and then to be able to make predictions based upon that data for the future. Not necessarily for being able to use those predictions as anything that we would benchmark students or, in our case, clients against, but it's something that allows us to help with forecast planning and allows us to help our clients with forecast planning. Because at the end of it, what you get, you can link this into any application you've built, but once it's run through this process, what's particularly interesting, as long as you've got to the point where you've got a really kind of fairly close model, and we'll see here, it tells you how accurate, so 0.79 accuracy score, and I can also then go in and I can evaluate how accurate the model is. In a second. And the blue lines in the center, the blue blocks in the center, represent how accurately it's made the prediction based upon the data. So at a high band, it's 61% accurate, low band, 68% accurate, middle band, 82% accurate. The very high band was 100% accurate, and you can tweak the information to change that. So you know you've got something, as long as you put enough data in and you know you've got something that's reasonably close to what you want. But then here's the interesting thing. You can then start to play around by putting in different scores and being able to see what the machine predicts that the outcome can be. And as I say, this is something that's available in different environments nowadays. And here it's predicting that middle is the most likely outcome with these individual scores. I have a learning availability of middle in there. Okay. So once again, this is the core of a lot of the work that we do nowadays. Again, it's not necessarily about trying to kind of create a wholesale system from start to finish that manages and controls and creates a flow for the learner from start to finish. If we go back to the Pedagogo example that I was talking about earlier on, that's a tool in which we use this to predict for our own benefit what we think the output will be, just to see whether or not we're actually accurately, whether the assessment marks are matching what the predicted marks are in there as well. So that's quite an interesting example. Okay, I'm conscious I only have 5 minutes left, so let me just talk very quickly about text analysis. Text analysis is also a very interesting tool that's being used. So the ability to take free text and to be able to analyze free text and make assumptions and judgments from that, that's something where I think we're kind of at level one. Where we use this a lot is the ability to be able to take content, large-scale content. Now, so we've done an application which takes a constant, and many other companies have done the same thing, takes a constant stream of Twitter data based upon a brand's requirements, and then we're able to predict the sentiment that those Twitter streams are referring to in response to a particular marketing campaign. This is the kind of, again, this is another Amazon tool, allows you to take text, it will break the text down and categorize it into different entities and so on. It will allow you to see the language predict the language that's being used, and here it will tell you whether it's a positive or negative element that is in there anyway. So this is something I would say is a very good start point. You're able to crunch the data down into individual text elements, and then you're able to feed that data, that textual information, into a machine learning algorithm, which will then allow you to be able to make predictions, like I said before. So instead of taking a spreadsheet of the type that I showed you before, you may very well pre-process the information using a text analysis engine. Again, you don't need to put any code in there, and then take that into the machine learning tool, which in turn will then allow you to generate and create outcomes, predictions, search for anomalies within those text, which forms the basis of a lot of work nowadays. And as a final piece here, because as I say, I'm kind of just conscious of the time that's in here. The other way in which we are actually, the other way in which we're working, which machine learning is working a lot, and again, this is something that we've done a couple of examples of, is using artificial intelligence to help the development of cross-curriculum schedules. So clearly, in many ways, one of the simplest things is to be able to take a schedule and to be able to generate a new schedule from it, to be able to take the input information and practically to be able to turn that into something that is available and usable for delivery of classroom schedules or for delivery of training schedules. Now, this exists in a lot of applications nowadays, but there are a couple of things that are interesting. Because when we started to do this for a couple of clients that we've done this for, what you start to discover is it's not quite as straightforward as that, because you've got to build in areas of redundancy. You've got to build in areas to do with the weighting that a particular subject matter expert has. You've got to build in the flexibility for sickness and so on. And so you go from something which you think is, okay, this is just going to be a rules-based analysis. It's basically just a case of putting in these rules and then the system will work it out. But suddenly you find that although it creates this beautiful schedule, it's not actually real. It can't be really attained. So there's a lot of work being done. There's a lot of very good tools that are out there. But this is a particularly interesting paper, which it formed the basis of some work that we did. Again, this wasn't for a training element. This was for an organizational element for organizing appraisals. But the point here is that these people tried to put together, in the International Journal of Machine Learning and Computing in 2012, tried to put together an algorithm which would compute would allow you to compute a successful schedule for any different environment that you could put in. Now, how successful they were, I think is questionable. I would say that, from our experience, they got about half the way there, and there's still a lot of blood, sweat, and tears to go into there. But again, it forms the basis of everything that's there. So that's been a lightning tour through some of the tools that we use, some of the experiences that we've had. I think the most important thing that I would like to give you as a takeaway from this is that, AI is here. There are a lot of things out there that can, in a very practical way, be used either on their own as augmentations to what you're doing today, or they can be used to be built into larger scale applications that can take the information that you've already got within your organization, and without actually having to recreate the wheel or change massive processes or anything like that, you can actually start to derive valuable input through the various tools that are available into that. Phew. So, thank you all very much. We're doing a Q&A, I think, at the end of the session. So if anybody has any questions, I'm very happy to answer them after James has finished his presentation as well. So thank you very much.
Thank you to both of our speakers. We do have a little bit of time for Q&A, so we'll go around with the microphone. Does anyone have a question for either James or Matt? Anyone thinking, I want my drink? Yes.
With the recommender engine, how do you feed back performance into that so that you know that you're recommending not what's popular, but what's effective?
Okay. Two answers. When you go out of the supermarket, you hit the smiley face for your experience. That's the simple way. The more effective way is by tracking at every single individual learner level for every single learning activity what the completion rate was, what the NPS score that they generated was, and what the people in their roles employee engagement level was. And we've now got direct correlation between learning effectiveness, learner engagement, employee engagement, customer revenue. So we literally know how to turn the tap of learning to get more customer revenue.
And is there any evidence showing that NPS score relates to effectiveness? Because I thought that was kind of disproved. No?
But very happy to carry this conversation on in more detail, but beg to differ. We have tried just about every single metrics system there is. One, the act of learning, almost irrespective of what it is, drives engagement. The more engaged employee, more engaged customer. That's sort of proven. Can you then work out which bits of learning go all the way through to which bits of customer spend? That's what we think we've cracked. The reason for NPS is you have to have one mechanism consistent across the whole framework. And we went before what we put in, before then, we were just negative on NPS. We're now plus 50 on NPS. And because we're tracking the whole time which people in which roles are learning what, and what their performance was of people in that role, we're able then to nudge other people in that role to learn that same thing. And NPS is sort of lingua franca of metrics, we have found. Carry on after.
Thank you, that was a great session. You talked a lot about cognition, and I guess my question is that what we've seen is hugely interesting in terms of knowledge building. Does the same approach work when you've got to challenge people's attitudes and you need to change their behaviours?
Lovely question, thank you. It's a harder one to prove, but if one, the short answer is yes, and we think we have. if you can track the rise in employee engagement, we see that as correlated to the style of behavior that we want. The other thing is that a lot of people behave in ways that you don't want them to when they're fearful, when they're protective of a current situation, maybe afraid of a little bit of change. The fact that 95% of the learning is free breaks down that barrier of, oh, I could actually go and learn about Agile even though I can hardly spell it. Therefore, I might just quietly go and have a little look at what it's all about, and then maybe just lower that fear level a little bit. I seem to be taking...
Come up and have a seat, make it easier.
Yes. Yeah.
We have these lovely company chairs that are good, yes.
This is actually for both of you. Both days you're hearing about AI, and most of us, we are only learning professionals. And we listen also that, we hear also that you have to learn and know about AI. But how? Which part of AI should we be learning? I mean, let's say that I am at the EBM Learning Experience Platform, and I put there, I want to learn AI, and I'm a learning professional. Which type of stuff the platform would be offering me, and what you think we should be learning?
Do you want to start?
Well, I think it kind of, from my side, I think it depends on what you actually want to use it for. Because I think if you've got a generalized interest in AI, then using any platform to learn it from is fine. But I think the most valuable, from my, sorry, I think that I'll stop fiddling. The most valuable way from my experience of learning is by actually getting into, in the case of, like I said, the work we do, AWS, but it could be the IBM Cloud, it could be Azure, you know, and actually trying out some of these tools. But then again, you know, just trying them out without having context is, unless you're actually academically interested in it, I think it really depends on what you want to use it for, and then finding the correct tool for that use case. You know.
Yeah. So just building on that, my answer would be twofold. First is NLU, and then is Q&A pairs. So NLU, natural language understanding, and everybody here, you can Google NLU, and 10 minutes later you will understand what natural language understanding is. You will then find a wonderful aha moment of, that's that blooming thing stands for. And when you accept that you can have a computer, to an extent, understand the meaning of a sentence, then you're off. Second half is Q&A pairs for a chatbot. If you haven't tried a chatbot yet, knock yourself out. You can go make one, Amazon, IBM Cloud, whatever. We went a bit crazy and we allowed anybody to make a chatbot for anything. It's a bit like having too many nephews or godchildren. We ended up with blooming chaos all over the place. But actually it was fine because people went, oh, look at my chatbot. It took me 2 hours or 2 days or 2 weeks, whatever. And then gradually it was, well, I prefer the look of yours. Can I join mine to yours? And now we have a nice family of chatbots. And once you understand Q&A pairs, you can then move on to the cognitive level when you apply NLU, because Q&A pairs are fairly static. If they ask this, tell them that. Whereas NLU then allows you to take it to the next level of reasoning.
So this question is for either a person or both. You were speaking, you're both speaking a little bit about how, specifically with Watson, how it's able to kind of, ask you questions and then recommend kind of, hey, well, you might want to learn more based on this, or kind of break down subjects, maybe dissolve books into little tiny bits and then recommend that from there. What I'm wondering though is that's, having worked a lot in skilling and in this type of content where it's fact-based and you're acquiring knowledge and these kinds of things, that makes sense. But in situations where you're talking about conflict resolution or leadership skills or these kinds of things where you have to somehow assess how good a person is at being a human, and you know what I mean, at how their emotions function in a critical situation, or how their ability is to say negotiate their salary with their boss. How do you see AI being able to A, assess that, and B, answer that with an appropriate piece of knowledge or practice?
You want to start? Today, imperfectly, would be my glib answer. If I could separate your question into the two halves, there's understanding human emotions is a somewhat harder one to crack, and what exactly is going on in their mind. However, I just basic level of research into neuroplasticity and so on, and one of the reasons that organizations have such a problem with change is because of fear. And if you can address that perfectly rational human emotion of fear by saying you can reskill yourself, it is a step towards lowering that fear. The point about can you teach them how to behave better? We are, most of us, tribe-friendly people. We like watching each other's behavior. We tend to morph in a group. And it is incredible when you don't put a team leader on a group of 10, how they will work out how to resolve something. We're smart animals. Nudging people in the right direction, rather than telling them you must learn this or you mustn't learn that, just nudging them in the right direction, we think is very powerful.
Yeah, I would agree, and I think it's a great question because the answer is really we're not there yet. But I also think that I'm not even sure if that's necessarily a desirable outcome, because I think that however much and there are various things where people are looking at how you can analyze emotion based upon facial reactions. You can analyze it based upon sensors and all of those sorts of things. But actually, it feels to me like we're a long way away from that. And also, if we were ever to get to the point where that could be a completely automated process, I still don't think you would ever be able to quite replace what the human brings to it, certainly from my experience. Yeah, I think we're a long way from that.
We have time for one more question.
Thanks, David. Thanks for a very interesting session, really challenging my thinking, certainly. And if we look at the model of trying to create business impact through learning, and we're looking at, well, what's the outcome we're trying to create or the business problem we're trying to solve, the behaviours that we need to do that, therefore what's the learning that needs to be in place to create that, what I'm hearing is almost we're saying, actually, it's just about learning. It's not about linking it to a specific problem that we're trying to solve, and that the learning itself is what creates the engagement and therefore the business improvement or the business outcome. Is that what I'm hearing, or have I...
That is a strong part of our findings, yes. That the desire to learn or top up, stuff you probably knew already but just want a quick top up, to then take to problem solving and to learn how other people have solved it and then expand it out to a giant scale of crowdsourcing of experience, skills, knowledge and learned behaviours. We would, well, from our own experience, we have found to be a highly effective way of building the capability of the workforce, which is ultimately what we want to do.
Interesting. Thank you.
I want to thank you all for coming to today's session. How about another hand for our two speakers here today? Thank you both so much for being a part of this conference. And again, I want to thank you all for being a part of Learning Technologies here. I hope the conference delivered upon what you came here for. What I always end my conferences the same way. What happens during the time we're together at the conference doesn't matter nearly as much as what we do when we leave those doors. So keep sharing the stories of how you're applying what you learned here the 2 days amongst each other, and we look forward to seeing you back at the conference next year. Thanks very much, everybody.